Applications of state space analysis in real life. In modern world, we are using more advanced and complex systems. We are not dealing with smaller and simple systems in traditional methods. The traditional methods we are using single input and single output systems, but instead of in modern systems we are dealing with multiple inputs, multiple outputs and dynamic behavior changes with respect to time. For example, if we consider the electric vehicles, robotics and automation and aerospace systems and consider the smart systems. So for analyzing these systems, we require a powerful method. So engineers choose one of the powerful method is a state space analysis. For state space analysis, we are dealing with in matrix format. So we are dealing with state variables, differential equations and matrix format. So state space analysis requires a complex internal behavior analysis systems and it gives a efficient output for internal behaviors of the systems. So that's why we are choosing state space analysis in modern control systems. So let's continue, Marsha.
The state space analysis is very important because it helps us to handle complex real-life systems. So we can say, unlike the traditional systems which is transfer functions, it works for a simple system, but it is not suitable for a complex problem. Thus, here comes our state space analysis. So basically, the state space analysis, it helps us to design better systems and also control and understand the system. So it also includes some important topics like controllability, observability and state feedbacks, so which helps to improve the efficiency and stability of the system. So some of the applications of the state space analysis are electric vehicles and robotics, power systems, and also we can say there are many applications in our smart systems. So in this discussion we'll see how these applications work and how state space analysis helps us in real life applications.
The state space, now let's see the application based on electrical vehicles. In EV vehicles, there are so many components like motor, battery, controller, etc. They all work together and make the car move. In batteries, motor, controller, etc. They all work together and make the car move. The stable state represent the equation in a simple manner. So the engineers can grade it and make the car more efficient, more reliable, and easy to use.
Nowadays, EV also plays a key role in robotics. Robots are a complex system which uses multiple joints, multiple motors, and coordinated movements at the same time. Using the state space analysis, we can combine all these to separate states, which helps achieve accuracy, stable movement, and a coordinated movement. For example, this robotic arm is used in industries and surgeries, which requires high precision.
So yeah, talking about the applications. So there is an important application in aerospace. So aerospace has spacecrafts and aircrafts, which is a dynamic system. So engineers use state space analysis to ensure that the aircrafts or the spacecrafts are like stable and to maintain the position and direction of the aircrafts. The stability of the aircrafts and also to maintain the position and direction of it. So this is also used in autopilot. So this ensures that it is stable and also it ensures that the aircraft is safe. And about autopilot, so autopilot relies on the position and the altitude of the aircraft. So this plays a critical role in the aviation.
Application in power system. In modern power system, it includes smart grids and renewable energy sources. The system requires continued monitoring and stability control. By using this state space analysis, engineers analyze the stability and voltage frequency to maintain the load variable failures, and it helps to stabilize the power system. It helps in major role. It plays major role in modern power system.
So can anyone discuss about the applications of state space analysis in industrial automation?
So, if I speak about industrial automation, there is no industries without state space analysis. To analyze all these complex problems, we need some method which is called state space analysis. So, if I speak about examples, we can have chemical industries, oil industries, refineries, etc. And why do we use state space analysis in refineries? In refineries, to analyze the temperature of oil, heat, etc., we need a state space analysis. Other than all these industries, we can use in electrical machines industries to analyze the motors, AC drivers, DC drivers, etc. We need two main things. One is a predictive analysis model, and another is observer model. These two will help in completing the state space analysis. So this is all about industrial automation.
So now let's move on to the conclusion part of this discussion.
So now let me conclude this and summarize. So far we have seen a lot of applications in a lot of fields. So the common thing is systems are complex. So you have to deal with and control the system and make it optimizable. So the main concept here is steady state. Concept here is the state space analysis. So it has become one of the most powerful and modern technology every future engineer should have. So we have seen a lot of applications thinking about EV, so which is to control the water and battery. And in power systems and aerospace, where reliability is important. And coming to robotics, like controlling a robotic arm, so where precision is important. And all the fields what we have seen, the common thing is like systems are complex and dynamic. The thing we have to understand is that we have to make a precise control over the system. So as to have a good precision over the control of the system, so we have to understand this analysis. So which helps us to make the system controllable and optimizable and better work.
Thank you.